Hi, so next we estimate the optimal classification tree using the tree function in R. So remember that we have several steps to estimate classification tree or regression tree. So first, they make a large tree, then estimate hyperparameter, then prune the tree to get the optimal one. So it suffers from overfitting often. So we use validation approach. So we make training set and test sets. And then we use training set to run this procedure. Then finally, that we estimate the prediction power using this test set. Okay, we go back to the R screen. We use library tree, library ISLR for data, and we defined the binary response variable high. Then we delete the quantitative continuous predict the response variable cells. So now we use this data dataset D. So at first, we have to define the training set and the test set. So at first, we set seed, any number. Then training set. Training set is 200 observations from the 400 observations in the dataset. So we define using sample function that we choose 200 observations out of 1 to 400. So this is indexes for training set. And also we want to define test set. So this is complement of this training set. So set diff 1 to 400 minus training set. So this is indexes for test set. So we want to define the training set and the test set. So we define DTRN as training set and the TST as test set. So now we want to fit the tree using training set. So TR2 is tree of high on all other variables for training set. So we can check the in-sample fit of this tree. So predict TR2, then we still use the same training set, DTRN, and this is classification tree, so class. Then you can check the table of actual response and predicted. So this is actual versus predicted. So actually this tree is pretty good in the sense that only 8 plus 12, 20 observations are incorrect. So error rate is only 10% in this case. Yep. So now that we want to optimize the number of nodes. So this is very large tree. You can get the summary of TR2. So this is a tree with 18 nodes. So this is basically an overfit situation. So that's why the error is very small. Now we want to optimize the number of nodes that is likely to be much smaller than 18. So we want to do cross-validation to estimate the optimal size of tree. So again, we fix some random seed, then we do cross-validation by using the cv.tree function. So using this tree, we prune the tree and we use the misclassification rate as a criterion to choose a tree. So that we use this prune.misclass function here. Then this is cross-validated result. So this is the size of the tree. So the largest tree is 18, and this is smaller one and the smaller one. And this k is corresponding hyperparameter. For example, the tree of size 2 corresponds to hyperparameter of 15. So larger hyperparameter penalize the tree size more, so we result in a smaller tree. And this is the error rate, and basically this is the misclassified observations. So out of 200 observations in total. So the minimum is 40, and actually when the tree size is 6 or 5. So in terms of cross-validated error, the tree size of 6 or 5 is optimal. So 5 is simpler, and the simpler model is better. So we choose 5 for this case. So you can make a scatter plot if you have the too many trees here. We only have the 10 here, but if we have more, we can make a plot. So TR2 CV size and TR2 CV deviance. So this is misclassified and just a plot. So then you can see that when tree size is 5 or 6, the misclassified observation is smallest in terms of cross-validation. So that we choose 5 or 6. So now we want to prune the tree. So to prune the tree, we use prune misclass function. So original tree is this, but we only have the 5 nodes, so that we choose the best is equal to 5. So this best basically means the tree size. So now you get the tree here. Yeah. So this is the tree. So you can see the tree. So this is the first node. So at first the price is less than 92.5 or price is more than 92.5. And if price is more than 92.5, then we divide this by the shelf location and so on. And finally, the terminal nodes are here, indicated by asterisk. So we have 5 nodes here. So this is the tree. So you can check the test performance of the tree. So we define the predicted value as predict TR2P, comma, the DTST test set, and the type is classification. And you can check the structure of this. You can see actually just no or yes, so that we get the predicted value. So now that we can get the table of prediction and actual. So predicted value is here, and actual value is here. So the D $ high and the T ST and the TR2P dot red. So actually this. So this one isn't really bad, but at least the 34.20 observations are incorrect. So that is 200 over 54. This is error rate, test error rate. So 27% incorrect. So compared with the training error, so training error was reported before here. So only 10% training error. But actually, this is the full-size tree, but after we optimize the number of observations, then optimize the number of nodes, then finally our classification error is 27%. And this isn't really bad, but in some cases, the even error becomes 40% or 45% in the same data. So it really depends on the randomness of the cross-validation. So this is how to estimate the classification tree by steps. And we have several other possibilities to there are several other commands to estimate the same thing. So another way is to use this hyperparameter. So remember that the tree size 5 corresponds to hyperparameter of 3. So you can see the k is equal to 3 corresponds to the tree size of 5. So you can use this function also. Then yeah, so you can just make the summary of TR2P2. So this is actually the same as the TR2P. So you have the same one. So sometimes we have slightly different one. So I think the command, if you specify k, sometimes it has some bug and the terminal nodes, the number of terminal nodes is slightly different from this. But basically we have the same calculation. So there are several other ways. For example, also we can use the prune tree function. So prune tree of this and method miss class and k is equal to 3.0. So we have the same output with this command. If we change the method to deviance, it becomes different function because the deviance basically is more detailed information than error rate. So it chose actually the larger tree. But this is because we use the different criterion. So we have several options to get the pruned tree. So either prune.tree function or prune.missclass function. So this is the complete procedure to estimate classification tree. So next time that we discuss the regression tree. Okay, see you then.